Chapter 10, Section 5. Let's see the new things that we cover today. Tangent and point of tangency. We have run across this word tangent before when we were talking about trig ratios. Do you remember what the ratio was in SOHCAHTOA? Do you remember what the tangent ratio was?
Oh, yeah. Opposite over adjacent.
Opposite over adjacent. In a right triangle, opposite leg over adjacent leg, that's the tangent ratio. Well, you know how English works. We use words over and over again, right?
Yeah.
I mean, one word can mean about 16 different things. Maybe a little less than that. But yes, sir.
Are you wearing a mic?
No. But there's a mic right over there that's picking us up. So we're good.
I mean,
Probably not picking you up as well as me. Tangent, in the sense we are using it today, is a line or a segment or a plane that hits a arc, which can be part of a circle, in exactly one point. So here's an example of a tangent. This line AB is tangent to circle C. It intersects that circle in exactly one point. Now, you can't really draw that, so it looks like it hits it at a whole bunch of points. But you can understand that if I have a curve, I can't have a line that just hits in one point, just barely touches it. That's called a tangent line, or a tangent segment, or a tangent plane. If you rest a ball on top of a table, if you could get down to the small enough level, it is tangent. It's just hitting it in one point, in one spot down there, unless your ball kind of flat on the bottom. The point that it hits is called the point of tangency. Easy enough. Common tangents. If we have more than one circle, well, we may have common tangents, which simply means they're tangent to both circles. So here line L is a common tangent. Here line L is a common tangent. These circles, in fact, are just hitting each other in one point, whether it looks like it in the diagram or not. And that line comes through and just hits at that one point. So you'll have to use your imagination a little, because drawing is a little difficult. So right down here, they are wanting us to draw the common tangents. But if no common tangents exist, state that there are no common tangents. So you're going to have an opportunity. So I've got the tools selected. I want somebody to volunteer and draw all the possible common tangents for A up here for me. First brave volunteer. David. You're the man. Come on.
okay.
Yeah. Just pick up a pen. It's already a segment tool, and so draw a line. Draw me all the common tangents.
All
For A.
For A.
Yeah.
Like I circle them?
No, draw them. Draw the tangent
The
line.
line.
Draw the line. That's a tangent. Did you change your mind?
Yeah.
All right.
Yeah,
Seth,
I changed my mind.
come on up.
Yeah. I think I
All right.
Oh, no, there's no common tangent.
Okay, he's saying there's no common tangent. Jonathan?
Wait.
Jonathan, come on up.
I got this. Yeah.
Oh,
I see it.
Oh, probably changed it a bit. Oh, well.
I was trying to no common tangent, but the pin was like glitching and
You can't. And we'll get the idea.
Yeah, there you go, Jonathan. Jonathan.
Yes, yeah.
Yes?
Oh, I knew it.
Yes?
Yeah.
I agree. Those are the two common tangents. B, I need another volunteer.
I got it.
B.
I got it.
All right, Logan, you've got this.
Yeah.
Oh, dude, no.
So there isn't one.
Oh, you're saying no common tangent?
Although.
There's has to be just one or multiple.
That's what we're asking you.
All right. Okay.
That's it. I'm so dead. Oh my goodness.
I thought it saw
That's okay. That's okay. We get the idea.
It's okay, Josh.
What?
Oh,
Yeah, that's
yes,
right.
sir.
What in the world?
I agree. There are four of them. There are four of them. There's a common tangent, see mine's not any better, that comes that way. There's a common tangent that comes this way. And then you could come like this. Common tangent. And like this. Common tangent. Excellent. Very good.
If there's like a crack, can you go between the cracks?
I'm sorry.
Not sure I followed you on
That's
that.
not okay, but like 1A, there's like a, they meet. Can you go in between that crack?
No. Can you come through here? No.
No. 1A. Down. Can you go in between the crevice?
Oh, down here? Well, that's my next question. I need a volunteer for 1A.
I don't know.
And you'll have to select the segment tool when you pick up the pen, if you wanted to have a segment. So, right by the eraser? No, right here. Let's try that again. Okay, we got it.
Fail him right now.
I didn't draw two.
All right. Yeah, it's hard to do it like that. But we get the idea.
You're gonna be a pro like this.
And a boy.
We get the idea.
That's my
Perfect.
question.
Oh, that last.
There's the answer to your question. There are 3 of them on that one. Okay, I need 1B. So let me go with Gerard. So
I know that.
you come up.
I know this one.
Boom. That's it.
There it is. That's it.
Oh, no, the secret.
All right. Very good. There are the commentaries. Okay. Let me have your attention now.
Okay, is there no?
Yeah, exactly. I want to know that as well.
Yeah.
Whenever there's a circle completely inside a circle.
But that was, there was that one too. But there's
That's
obviously.
not completely inside a circle.
Oh.
Oh.
There you
go, Seth. I'm donut.
You couldn't be tangent to both of those because you'd have to go through one circle to get to another circle. Couldn't be common tangent. All of their examples there were common tangents. Theorem 1010. So listen up now. Thank you. In a plane, a line is tangent to a circle, so here's our line L, if and only if it is perpendicular to the radius drawn to the point of tangency.
How could it not be?
So right here is our point of tangency. And what they are saying is if I draw a radius down there, it has to be perpendicular.
I have a question. How can it not be perpendicular to this radius? Like, can you draw an example?
It can't not be. It is. If it's a tangent, it will be perpendicular is what this is saying.
Can you draw one that's not a tangent? Like, that's touching the circle but not perpendicular to?
Yes, it won't be a tangent line, which means it is going to be a line that comes through it. This is not necessarily tangent. I mean perpendicular. That's not necessarily perpendicular. Could I draw a perpendicular somewhere? Yeah, I could, but not to the point where it intersects the circle. So the only time we have this perpendicular is if it's a tangent line and we draw to the point of tangency. So down here it says determine whether segment GH in that figure is a tangent. So how do we know if that is a tangent? What could we test?
If that's the right angle.
If that's a right angle, how can we test if that's a right angle?
Measure.
The Pythagorean theorem. So help me out with the Pythagorean theorem. You tell me the numbers that I would...
8 squared times 6 squared.
8 squared plus 6 squared.
Equals 12 squared.
No.
No, it's
Well, 12 is that right there, whether it looks like it or not. Well,
It's got to be H to F.
it's got to be H to F, doesn't it?
Yeah.
They put it at a bad spot. 8 squared is how much?
64.
6 squared?
36.
12 squared?
144.
Are those equal to each other?
No.
Not even.
No.
Find the value of x so that the segments that appear to be tangent actually are tangent.
Oh, X squared.
There you go. This would have to be true. It would have to be a right triangle. Pythagorean theorem would have to be true. So I can subtract that 14 squared, and I'll let you do a little math for me here. Figure out the answer. Doesn't come out exact, huh? Oh, tell me the number, the radicand, the number inside that square root.
In square root of 93.
93?
Yes.
Is that what it is? Okay. Approximately 9.6. So exact answer squared of 93, approximately 9.6. This one up here.
Okay. Come on.
Wait, what?
Oh, we're going to have to think a little bit, but you can do that.
2 plus x, and it's going to be x squared.
2 plus x. 2 plus x would be the what?
S to R.
The hypotenuse. So I'm going to put it over here. 2 plus x squared, because that would be the hypotenuse.
Mr. Fisher thought S could be a hypotenuse. Wouldn't S to R be the
S to R would be the hypotenuse of this one. That is the one that is going to be the right angle if it is tangent.
Would you do 4 squared?
This is a tangent line, maybe. If it's perpendicular, we know it is a tangent line.
Oh,
Logan, what?
4 squared plus x squared, because you're trying to find
4 squared.
OR.
I need 4 squared. And where'd you get this x squared from?
OR. The radius.
Yeah, that's a cube, but that's okay. That's the radius. X is the radius. So x is the radius down here is the same length x, the radius up here. There you go. Now we're going to have to multiply that thing out. 16 plus x squared equals, what does it mean to square something?
You count it by itself.
You multiply it by itself. So we'll multiply this by itself, because that's what it means to square. Do you remember how to multiply binomials together?
12.
First terms. 4. Outside. 2x. Inside. 2x. It'll be a total of 4x. Last terms? X squared. So any suggestions? We're down to some algebra here of what I can do next. Yeah, subtract x squared. If I subtracted x squared from each side, they're just gone. Then we can subtract our 4. So x equals 3. So if x is 3, I guess that's what they wanted to do, huh? Find the value of x. X is going to have to be 3. Get your compass out. And today is the day that I am giving points for you showing me your compass. So just hold up your compass. Is there a compass there? Is there a compass? All right.
Yeah.
Okay, I got them all. Thank you. We are going to learn how to construct tangent lines to a circle. Oh, thank you. So the first thing to do, take out your paper. You'll do homework on this paper a little bit later from the book. Come down a ways so that you have room to make yourself a circle. Now you need to identify where the center of that circle is going to be, so I'm going to call it C, because when I spell center, that's how center is spelled. And then use your compass and make a circle that is a nice size circle, because we're doing construction, so we need figures that are large enough to be measuring. So there we go. There's a nice size circle for me. So the first thing to do is put your dot where your center of your circle is going to be. Draw your circle. Next, come off beside that and make a point. I'm going to call it point P, because once again, when I spell point, that's how I spell point. So it doesn't matter where it is, but have it a ways away from that circle. So it's at least a diameter or so away from that circle. It needs to be a ways away from the circle. Our goal is going to be constructing the two tangents that come from point P and hit that circle. Now you can just estimate and say, I'm going to lay a ruler down to draw a line. But a construction, we're going to get the exact location. So step number one, after you have set this up, is take your straight edge, and we want a segment between the center and point P. So use your straight edge and just draw a segment that goes from the center of the circle right to point P. And our constructions always take a straight edge and a compass.
Anybody else want to do it on the bottom?
Okay, so you have drawn your segment between the center and P. Now we are going to want to find the midpoint of the segment. So there's a way to use your compass to find the midpoint of that segment. You'll take your compass, you'll set it on one end of that. So right there is one end of my segment. You need to open your compass up so that is wider than halfway. So I have my compass opened up so that I know it's wider than halfway there. And then above, make a nice arc like this. Rotate it down. Don't let it change sizes. Make an arc down here. Flip to the other end. Don't let it change sizes. Flip to the other end. Put your point over there. And cross the arc above. So you'll get a little arc up there. Keep it the same size. Come down here. Cross that. So you've got a couple of X's. Now use your straight edge to put where those X's are so that you can just put a mark on the line where it intercepts. All I really care about is knowing where is the midpoint. Right there. So if you just put your straight edge up there and put a mark right there so we know the midpoint of CP. Now, take your compass again, and this time, put your point right on that midpoint location. So the point of your compass should be right there, and then open your compass up so that it is exactly the length, see if I can get mine over here, that reaches the center of the circle. That's exactly the size we want your compass to be. So that size, now rotate your compass up and put a mark where it crosses the circle. And rotate it down so you put a mark where it crosses the circle. I'm just going to move this out of the way for a moment. Where these two arcs cross the circle, those are your points of tangency. So you should be able to take your straight edge now and go from point P and hit exactly at those locations, and those are exactly tangent lines, the exact points of tangency. And again, depending on how good a job you did with your construction, that's how good a result that you are going to get from this one. Yours is perfect. Excellent. If yours is perfect. So how do we know this is true? Here's how we know what's true. What we did when we put our compass at the midpoint and then to the circle is it's the center of a circle. We didn't draw the whole circle, but that's like the center of a circle. And then if I drew from point A up here, that's our point P on the end. If I drew from A to D, drawing from A to D, in this big circle, and then from D down to C, what I have in this is an angle, an inscribed angle that intercepts a diameter. And do you remember what the measure of that inscribed angle is if it intercepts a diameter or a semicircle? 90 degrees. What we really have done is we've made a 90-degree angle right there. And if it's a 90-degree angle, then it must be a perpendicular line to the tangent line. So it's using a couple of ideas, theorems, in order to make this happen. So that's the process of constructing a tangent. I'm trying to get rid of this thing. Oh well, I'll have to try to delete it later. It's not letting me delete it for some reason. Next theorem. If two segments from the same exterior point are tangent to a circle, this is the thing we just constructed, then they have to be congruent to each other. Those are going to be congruent to each other. Okay? So let's use that fact. Find the value of x, assume the segments appear to be tangent, actually are tangent. Well, this should be real easy. What can I set up? There you go. That has to be true. So 3x is going to equal 18. X is 6. Easy stuff. What do I know about 2x plus 9? It equals 3x plus 6. Going to subtract the 2x, so that gives me x. Subtract the 6, it gives us 3. There you go. So this fact that says two tangents from a common external point are congruent. Next fact, or I guess the next application of the fact. Remember we talked about inscribed and circumscribed? So here we have circumscribed polygons. These polygons have sides that are tangents. Each of these sides are tangents. Now over here these are not, because we don't have tangents on them. So right down here they say quadrilateral RSTU is circumscribed about circle J. If the perimeter happens to be 18, figure out what x is. Well, right here is 1x. Can you tell me how far it is from T to B? X. Because I have a tangent. T to B is a tangent and T to A is a tangent, so these have to be congruent to each other. How far is it from B to U? X. How far is it from C to R? 3. How far is it from S to D? 3. So that's not going to be too hard. Perimeter is adding all these things up. How many x's do we have?
4.
4x. Plus, how many 3's do we have?
3.
412? 4 3's? 4 3's? And they tell us it's supposed to equal 18. So 4x plus 12 is 18. 4x must equal 6. Fraction.
3 over 2.
There you go. 3 over 2. X must be 3 over 2. Worksheet. And some bookwork already. Easy stuff. Circles are just easy. You gotta stick around. Okay, 3.